So yesterday we started 4.4 with the Pythagorean theorem. Today we're going to finish 4.4. That's why it's 4.4 day 2. Today we're talking about the distance formula. So our objective is to find the distance between 2 points. We learn these two together because the distance formula uses the Pythagorean theorem. You're going to see 2 points on a coordinate plane. If you think of those as the hypotenuse, and the x values give you one side of the triangle, the y values give you the other side, and you're just looking for that missing side. That's the distance formula. So it is very similar to the Pythagorean theorem, just a little different. Any questions before we get going? Alright, I'm going to shorten this up for you just a bit. Write the distance formula. And then you can write this whole part right here, the if-then statement. And then this is that formula that follows. So I would actually just sneak this right up here. And then you can put a special box around this thing with some stars or smiley faces or something. This is the important part. This is the distance formula. We're going to use this for every single problem we do today. So if you have a point A located at x1, y1, and B located at x2, y2, if these are points on the coordinate plane, then the distance between those 2 points is the formula you see there, the square root of the x value subtracted squared plus the y value subtracted squared. I sort of told you why that works. I'll show you again. If you have, and you don't need this part in your notes, this is just a little background information. Let's say you have an ordered pair up here and an ordered pair back here. And I want to know the distance between these two. Well, when you subtract the x values, that gives you the side of a triangle. If you subtract the y values, that would give you this side of the triangle, and the hypotenuse ends up being the distance between those 2 points. So that's basically what they're doing here. They're saying subtract the x's, square it, that gives you a side, one of the legs. Subtract the y's, square it, that gives you the other leg. Add those together, that would be one side of the Pythagorean theorem. Would equal like the c squared part, and then to get c by itself you take the square root. So that's where this comes from. This is directly from the Pythagorean theorem. It's basically thinking of this as a right triangle. Finding the hypotenuse is the distance between the 2 points. Any questions on the distance formula or where it comes from? If you want a detailed proof, those are all over the internet, or I can show it to you a little later. I'm assuming most of you are okay with the condensed version. Alright, you do not need to write this one in your notes. I wanted to show you one on the board where you could just watch and soak it all in. So give me your full and undivided attention. No need to write it down. After we do this one, we're going to look at 6 examples in your notebook, and then you guys will have some time to do your homework. So you can see right here, these are the same ordered pairs as right here, right? So sometimes you'll be given a picture. Sometimes you'll just be given the points written out in the problem. Alright, we need to just first decide, well, what's what? So the first x I'm given, I'm going to call that x1. The first y I'm given, I'm going to call that y1. The second x I'm given, I'm going to call that x2. The second y I'm given, I'm going to call that y2. Any questions so far? Just labeling the numbers. You could label them on the coordinate plane if you'd like, or in the directions if you like, depending on the problem that you're given. Now I'm going to use D for distance. The distance is we have a big square root. You need to subtract the y, or sorry, excuse me, subtract the x's, square them, subtract the y's, square them, and then take the square root of that. So we just basically have to plug it in and simplify. What is... Subtract them, square them, and then add them. Yep. So I have the big square root. What is x2? Which is the second x value you were given? 4. Minus, what's the first x value you were given? -1. I'm going to square it. I'm not doing any math yet. You're getting a step ahead of me. All I'm doing is writing them out. Alright, then I want the second y, which is +2. The second y minus the first y. And I'm going to square that. Now, if you're really good with the calculator, you could actually type this whole step in and get the answer right away. You got to be careful with your parentheses, though. I can show you that in just a second. But I'm going to just do it by hand. What is 4 minus -1? Right. So it's just 5. So this is going to be 5 squared. Plus, what do I get back here?
4.
Yeah, 4 squared. What is 5 squared? What is 4 squared?
8.
That is the square root of 41. Type that in your calculators. 6.4 what? Okay, so yeah, 6.4, good. We are going to round all answers today to the nearest 10th. Or you could simplify the radical like we learned last week if that is something you are into. Alright, now I told you I'd tell you in a second how to type it in your calculator. If you want to type this in the calculator right here, you start by pressing the square root button. So you'd hit second and then like the x squared to get the square root. Do you notice that it opens a set of parentheses for you? You need to keep that and put another set. 4 minus, this needs to be a minus sign, this needs to be the negative sign. 1. Close the parentheses. So again, you should have the square root, 2 parentheses right next to each other. 4 minus -1, close one of the parentheses, square it. Plus, open a new set. 2 minus sign, negative sign, 2, close those parentheses, square it, and then close the original set that it opened for you and hit enter. So you'll need an extra set of parentheses to tell the calculator that this whole thing was under the radical.
I had an error.
I'll come and help you one-on-one if you're interested in that. Or a lot of students just forget about the square root. They do the parentheses 4 minus -1 squared plus 2 minus -2 squared. And that'll give you 41. And then they just type in square root of 41 and get that. So that might be a little easier if you want to save the square root to the very end. But I will come around now and help whoever needs it. Here are the first 3 examples we're going to look at. If you do not want to draw those graphs in your notebook, I do not blame you, but we still need those ordered pairs in your notebook, so let's just write them out. So you could just put problem number 1 and list the 2 ordered pairs. That's a -1, sorry. Then you can put problem number 2 and list the 2 ordered pairs. And problem number 3. And list the 2 ordered pairs. I always put the left one first and then the one on the right last. Really, it doesn't particularly matter in the distance formula, actually, so write them as you wish. And then for the first one, I'm going to do x1, y1. Bless you. x2, y2. And instead of writing the distance formula at the beginning of every single problem, I'm just going to write it at the top one big time, and I'm going to use that on each of them. What is the distance formula? What is the distance formula? Waiting on you guys.
Oh, -2.
In general, the distance formula, the first thing you wrote in your notes.
X squared
2 minus
x
1 squared plus
y 2 plus,
minus y1 squared, all in a big square root. Wow, you guys have got some work to do tonight, it appears. Alright, so let me start with that for my first one. What is my x2 in the first problem? 3 minus, what's my x1? -2. I'm going to square that. Plus, what is my y2? Minus, what is my y1? Four? Anybody? Anybody? Good. And then what am I missing? The big radical. Good. Now you can do it step by step. You can type it all in the calculator. You can type in everything but the square root and then take the square root at the end. It is up to you. But 3 minus -2, that is like 3 plus 2, so that's going to be 5 squared. In the back, that is going to be a -5 squared, and then I'm going to take the square root. Now, if you're typing this in the calculator, parentheses are key here as well, because this is not 5 squared, then you make it negative. It's -5 times -5. So if you don't put it in parentheses just as it is on the board, the calculator will give you the wrong sign. If you're getting a distance of 0, you obviously made a mistake. These are way farther apart than 0 units, all right? This should be 25 plus 25, which is the square root of 50. Can anyone tell me what they're getting when you type in square root 50 in your calculator? Probably 7 point something.
7.0.
What's after the 0?
7.1.
7.1. Very good. We're going to round to the nearest tenth. All right. Raise your hand if you've got questions. All right, let's start on that second one. So I will have a big square root. I'm going to label these x1, y1, and oops, x2, y2. So what is my x2? 5 minus, what's my x1? Okay, so I have 5 minus -2 squared plus, what is my y2? What is my y1? Squared. What is 5 minus -2? like 5 plus 2, right? So I have 7 squared plus, what is 5 minus 5? 0 squared. So that's going to be 7 squared plus 0, essentially. 7 squared is 49. What is the square root of 49? 7. So we are getting the distance between these 2 points to be 7. Well, since this is just a horizontal move between one point to the other, you could actually just count them. 1, 2, 3, 4, 5, 6, 7. It's exactly 7 units apart. Now, that doesn't really work on one like this because you're going diagonal, so don't try to do that on all of them. But if it is straight horizontal or straight vertical, you could actually just count. Kind of cool, right? Right? Yeah, thank you for humoring me. All right, let's do the last one on this page, and then we'll get to a few more. Then you have some homework time. Let me label these x1, y1, x2, y2. All right, what is my first number that I want in my parentheses? You always start with the x2, so what is that? So I have 4 minus, it's my x1. Negative 4. X is in the front. This is a y. So back here we'd have the 2 minus the negative 2. Alright, so you want to subtract your x's, square them, subtract your y's, square them. What's 4 minus negative 4?
8.
8, so I have 8 squared. Plus, what's 2 minus negative 2?
4 squared.
4 squared, good. So that will give me 64 plus 16, which is square root 80. I'm going to write it right up here so you can all see it. What do you get when you type in square root 80?
That's 4, so it's 8.9.
8.94, so it'll stay 8.9. Good, and think like if it was the square root of 81, that'd be 9, right? So it makes sense that it's just right below 9. All right, these are kind of tricky. They take some time. Your calculator is your best friend for this lesson. What are your questions so far? All right. Here are 3 more examples. Again, I'm going to start just by writing the distance formula on the very top. We're going to use this for every single problem. I would recommend you do this on your homework as well. Write it up top, loud and proud. We're going to do the x's, subtracted and squared, the y's, subtracted and squared, and then take the square root. As you are writing these down, I'm going to go through, and you can do this right when you get your homework. x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. We are ready to go. So, what is x2? Minus, what's x1? 0. I'm going to square that. I'm going to add it to, what's y2? 5 minus 0. I'm going to square that. I'm going to take the square root. I'll pause here so you can catch up. If you're already to this point, you can start doing some calculations. The zeros should help you out here because it's just going to be 2 squared and 5 squared. What is 2 squared? What is 5 squared? 4 plus 25 is 29. So when anyone gets the square root of 29, yell it out and I will write it down. 5 point what? 3.8, so that would round to 5.4. Now, I don't spend a lot of time talking about rounding because I'm assuming that's a skill you're very familiar with. If you need a little rounding lesson, you just let me know. Any questions on number 4? All right, we'll just keep on moving. Number 5, my x2 is -6. My x1 is minus 4. It's a regular 4, but I'm subtracting. You know what I mean. My y2 is -6. I'm going to subtract my y1, which is 2, and then I'm going to square them both. This is one where it's very important to keep track of your signs. This is going to be -10 squared. This one's going to be a -8 squared. If you're using the calculator, put the parentheses around it. -10 squared is -10 times -10. So should that be a positive or a negative 100? Positive. Same thing back here. We have -8 squared. So should that be 64 or -64? 64. Good. Anytime you're squaring these, they should be positive. If you end up with a negative under your square root, you probably just made a sign error and you need to go back a step. Square root of 164. Anybody have that for me? 12.80. So we'll keep it 12.8. Good. Questions on number 5? You guys need a little more time, or is everyone where I'm at? I'll take your silence to mean you are ready. Alright, what is my x2? Minus my x1. Very good. Square it. Plus, what is my y2? Minus, what is my y1? Square it. Good. Now, signs are tricky here. What's -4 minus -5? 1. So I have 1 squared plus, what is 5 minus 3? 2, so that's going to be 2 squared. I shall pause. Let's see if we can do a step in our heads. What is 1 squared? What is 2 squared? What's 1 plus 4? Okay, so in your calculator you need to type in square root 5. 2.23. So the 3 makes the 2 stay the same, so 2.2 is our answer. Alright, I'm going to leave those on the board. I know we went through the last 3 kind of quickly. I'm trying to give you a little time to do your homework. If you have questions, though, just raise your hand. If not, your homework tonight is 10 questions. Set up very similar to the ones that are on the board. You will not see graphs on here, but you probably will on your quizzes and tests coming up. So be aware of how those work as well. A lot more like 1, 2, 3.